Let's find out what is a cyclical quadrilateral and what are some special properties about a cyclical quadrilateral. So we have drawn a circle, any circle, and let's pick randomly 4 points on this circle. So here we have taken 4 points and I have named them A, B, C, D. Next, we are going to join these points A, B, C, D. So when we do that, we get a quadrilateral. Now this quadrilateral is known as a cyclical quadrilateral. And there is something unique about this quadrilateral. So quadrilateral, this has all 4 vertices on the same circle. And also what we notice is that if we were to add angle A plus angle C, that is the pair of opposite angles, if we were to add this angle and this angle, we will see that the sum of these two angles is equal to 180 degrees. And the same is true for angle B and D. So if we add angle B and angle D, we get 180 degrees. You can quickly do this construction at home and verify for yourself. This is always the case. No matter what radius you pick for the circle and no matter where you pick the 4 points, this is always the case. Next, we are going to find out why this is always true. So let's say here, this is our cyclical quadrilateral ABCD. We are going to do two quick construction. We are going to join the diagonals. So let's join diagonal BD and let's join diagonal AC. So at this point we have these angles. So let's call this angle, this small angle, that is angle DAC, let's call it angle A1. And let's call this angle, that is BAC, as A2. Similarly, we'll call this angle as B1. Let's call this angle as B2. And here this small angle is C1 and this angle is C2. Similarly, let's call this as D1 and D2. Now, let's focus on this arc CD. So the arc CD subtends two angles on the circle. So one is angle A, that is this arc CD subtends angle DAC at point A, and similarly this arc subtends angle B2 or DBC at point B. So by theorem, we can say that angle A1, which is this angle, is equal to angle B2. Why? Because we know that all angles subtended by the same arc on any other point in the circle will be same. That is the theorem. So angle A1 is equal to angle B2. Next, let's focus on arc AD. So it'll look like this. This is our arc AD. So it subtends angle B1 and C2. So these two angles must be equal, B1 and C2. So let's write it over here. Angle B1 is equal to angle C2. Now, if we were to focus on arc, let's say AB next, so we can say that angle C1 should be equal to angle D2. So let's write it over here. So angle C1 should be equal to angle D2. And finally, let's take a look at our arc BC. So angle D1 should be equal to angle A2. Angle D1 should be equal to angle A2. So we have gotten these 4 relationships. Now we also know that angle A plus angle B plus angle C plus angle D, what is the sum of all 4 angles? It's 360 degrees. Why? Well, these are internal angles of a quadrilateral, and when we add all 4 angles, we get 360 degrees, right? Now here, angle A1, we can split it into A1 plus A2. So instead of angle A1, we can write it as angle A. Angle A, we can write it as angle A1 plus angle A2. I know this looks all weird because usually we don't write it this way. Here I have, A1 and A2 and then I have an angle on top of it. But I'm just trying to do it a little faster. Instead of continuously writing angle DAC and angle CAB, I'm just using the shorthand. Similarly, angle B can be written as angle B1 plus angle B2. Angle C will be angle C1 plus angle C2, and then we will have angle D1 plus angle D2. So all of this will be equal to 360 degrees, right? Now this part is important. Now remember what we are trying to prove. We are trying to prove that angle A plus angle C is 180 degrees, and similarly we are trying to prove angle B plus angle D is equal to 180 degrees. So what we are going to do here is that we are going to write all these angles in terms of A and C first. so that we are trying to prove the first one. So let's start, and we can do the same for the second one as well. But let's try to replace all these angles. So we are having only angles A's and C's. So this angle is all right, right? So there's no change. They are both angle A. So let's do it over here. So we have angle A1 plus angle A2, which is this. Now we want to change this because this is angle B. So what can we replace angle B1 with? Well, let's say angle B1 is equal to angle C2. So instead of angle B1, we can write angle C2. Similarly, what about angle B2? For angle B2, we can write, let's see, B2 is equal to A1. So we can write this as angle A1. Then we have angle C. So we can write them as angle C1 plus angle C2. So we are good here. Plus, now for angle D1, we can replace angle D1 with A2. Right? So let's write it over here, angle A2. Plus, here we have D2. D2 we can replace with C1. C1. So this will be equal to 360 degrees. Now we have all angle A's and C's. So now angle A1 plus A2 is simply angle A, right? So let's do it over here. So this is angle A. These two, right? These two are angle A. Now similarly, we have another angle A1 and A2, which is this guy here and this guy here. So then that means we will get another angle A over here. Plus, now this is angle C2 and this is angle C1. So this is C2, this is C1. So if we combine them, we will get angle C. Plus, now we have angle C2 and C1, another one. So that will be angle C again. So we add them. So this is equal to 360 degrees. Or here, we have twice angle A plus angle C equal to 360 degrees. Or we can simply say that angle A plus angle C is equal to 360 divided by 2 or 180 degrees. And hence we have actually proven what we wanted to prove. So we see that angle A, which is this big angle, right, plus angle C, which is this big angle, is indeed equal to 180 degrees. So we don't really have to go ahead and prove the same for angle B, but I think let's clean this up. We could have also written it like this. Now that we have proved angle A plus angle C is equal to 180 degrees, right? So we know that angle A plus angle B plus angle C plus angle D, all four angles combined is 360 degrees. So if we have angle A plus angle C as 180, so then we have angle B plus angle D will be equal to 360 minus 180 degrees, or simply this will be also equal to 180 degrees. So we have proved that the sum of opposite pair of cyclical quadrilateral, so those angles are always 180 degrees.